Hello everyone, welcome to Excel Engineering Education. In this video, we will discuss about sway frame. Sway frame, whenever we want to solve with the MDM, that is moment distribution method, we have to divide this problem into two parts. One is a non-sway analysis and another is a sway analysis. Let us see how to solve this frame. The frame ABCD having a UDL for BC or 30 kilonewton per meter, and moment of inertia is varies from each member. So our first step is calculation of fixed end moment. Here for AB, BA, CD and DC there is no any load, that's why fixed end moments are 0. Now next, the fixed end moment for BC, due to the UDL it will be minus 30 into 6 square divided by 12, that is WL square by 12, which is 90 kilonewton meter. Again for CB will be the same, that is 30 into 6 square divided by 12, that is nothing but 90 kilonewton meter. This is plus we consider. Now whenever we want to solve MDM, our next step is distribution factor. Here there are two joints B and C. Let us write down a first joint having connecting the member BA and BC. For BA, B to the A is a far end which is fixed, that's why it is 4E into twice I divided by L. L is 6, so ultimately this answer is 4 by 3 EI. Next for BC, though both are intermediate, that's why it will be again the same, and I is 2I, that's why it will be 4 by 3 EI. For C joint, there is a connection of CB. CB is also where B is fixed due to intermediate support, it will be same as 4 by 3 EI. I is constant there for CB. And next is CD. Here when we consider a CD, D is far end and it is hinged, that's why it is thrice EI by L. L is 3, so ultimately this is EI. Now summation of K, that means summation of these two and summation of these two, which comes to 8 by 3 EI, and summation of this also, it is 7 by 3 EI. Now we want a distribution factor for each member. So how to calculate distribution factor? We already know that distribution factor is equal to K divided by summation of K, that is 4 by 3 EI divided by 8 by 3 EI. Ultimately this is, for BA it is 0.5, for BC it will be 0.5, for CB it will be 7 EI divided 4 by 3 EI divided by 7 by 3 EI, it will be 0.571, and again EI divided by 7.3 EI, it will be 0.429. Then our next step is moment distribution. Now we have to distribute these fixed end moments whatever we calculated. For that we have to prepare a table which is nothing but joint A, joint B, joint C and joint D. But for B we have fixed end moments. For A we have fixed end moment 0, AB, BA 0, CD, DC 0, but BC and CB have 90. But our distribution factors for B, it is 0.5, for BC it is again 0.5, for CB it is 0.571, and CD it is 0.429. So this is all about the distribution factor 0.429. Our fixed end moments are AB 0, BA 0, BC minus 90, CB it is 90, CD it is 0, and DC is also 0. This is all about our distribution factors and fixed end moment. Now we have to balance these moments, and also we have to transfer a half to the fixed end. Where we will transfer? We will transfer from B to the A. Yes, we will transfer from B to the A. B to this, because A is fixed. Can we transfer from B to the C? Yes, C is intermediate support, that's why it is fixed. We'll transfer to the B to the C, B to the A. But C to the B, yes, we will transfer from C to the B, because B is intermediate. From C to the D, no, we cannot transfer, because it is a simply supported or a roller support. So let us balance this. How to balance that? Whenever we want to balance it, we have to add these two values at a joint and multiply with the distribution factor and write down here with the opposite sign. So this is minus 90. It will going to be 45 and 45. Next, again it is plus 90 into, add this is 90 into 0 0.571 and 0 0.429. Ultimately it is minus 51.39 and minus 38.61. Now we have to transfer a half. Whenever we want to transfer a half from B to A, yes, we will going to transfer from B to A. Can we transfer from B to the C? Yes, we will transfer from B to the C also. Can we transfer from C to the B? Yes, we will transfer from C to the B also. But from C to the D, no, we cannot transfer. That's why 45 divided by 2, it is 22.5. Then 45 divided by 2, it is 22.5. This is 51.39. It is minus, that's why it is minus 25.70. Now next, what we have to multiply this 25.70 to 0.5 and 0.5. Similarly 22.5 to this 0.571 and 0.429 we have to write down at each column. So ultimately we will get a final answer, and we have to write down here with opposite sign, that is minus 25.70 into 0.5. It will be 12.85. So 12.85, and again here will be 12.85. 22.5 multiplied by 0.579, it is minus again 12.85, and next is minus 9.65. Now half we have to transfer. We have to transfer half, that is B to the A. Yes, we want to transfer. From B to the C, yes, we want to transfer. And from C to the B, yes, we will transfer from C to the B also. Therefore 12.85 divided by 2, it is 6.43. Again it is 6.43. This is minus 6.43. No, we don't want to transfer here. Now 6.43 multiplies with 0.5, 0.5, write down here with the opposite sign. So it will be 3.22, 3.22, again minus 3.67, and this will be minus 2.76. So these are the answers. Multiplying this with these two distribution factor, this with these two distribution factor, and write down the opposite sign of this addition. So now next we have to transfer half to the fixed end, from B to the A, from B to the C, and from C to the B. So 3.22 divided by 2, it will be 1.61. This will be 1.61. This will be minus 1.84. And now our next value we got, that is 1.84. Multiply with 0.5 and 0.5. We will repeat the same iteration. So it will be 0.92, 0.92, then minus 0.92, then minus 0.69. Now we have to transfer a half to the fixed end, from B to the A, from B to the C, from C to the B. So ultimately we will get an answer as 0.46. This will be minus 0.46. This will be 0.46. So now we'll do a last iteration. that is nothing but 0.46 to all these distribution factor. So it will be 0.23, it will be 0.23 same, this will be minus 0.26, and this will be minus 0.20 because it is a opposite sign we are writing. So ultimately this completes our iteration. Now we have to add all these values so that we will get a final moments, that is final moments after non-sway analysis. Now we will add from this 0 to this, we will get an answer as 31.00, this is 62.22, this is again minus 62.22, this will be 51.91, and this is minus 51.91, and this is 0 itself. Why it is 0? Because it is a simply supported end. Now our next step is step number 4 is a sway force. We want to calculate a sway force, but sway force will be where? It will be act on this column. Sway force itself, it is a horizontal force, so we can say that this is in this way, horizontal force, and that HA and HT that can be calculated. How to calculate that HA and HT? It's very simple formula, that is addition of these moments, that is moment at A and moment at B divided by its height. Moment at AB and moment at BA and then divided by its length, we will get a HA. Similarly for HD also, moment at D plus moment at C divided by its height, that is 3, we'll get an answer. So ultimately this can be written as 31 plus 62.22, that is these two divided by, what is the height? Height is 6 plus HD 3, and that is 3 meter is the height, and moment at C is only 1, that is minus 51.91 plus 0 divided by 3. So we'll get a sway force due to the non-sway analysis, that can be written as S is equal to, I think this is 55.54 minus 17.30. So sway force is equal to minus 1.76. So this is all about a sway force due to the non-sway analysis, which completes our step number 4. After the non-sway analysis, our second step is sway analysis. Let us consider step number 5. Let MF1 and MF2 be the fixed end moments in AB and CD, and delta is the sway. We already know one formula, which is a sinking of support. Sinking of support, that is nothing but 6EI delta divided by L square. So here delta is a sway. Now what we have to do, we have to take a ratio of MF1 and MF2, that is the sinking, somewhat sinking, that is somewhat deflection of a frame, that is nothing but using this formula, it will be 6E into twice I into delta divided by L is just 6 square divided by 6EI delta divided by 3 square. So ultimately this ratio, it comes to 1/2. Now we have to consider value of MF1. You can consider any value, but let us consider, this is our assumption, let us consider MF1 is equal to minus 50 kilonewton meter. So MF2 will be, ultimately this is the twice of this it will be minus 100 kilonewton meter. MF1 is for column AB and MF2 for column CD. That's why we can rewrite MFAB is equal to minus 50 kilonewton meter and MFBA is also minus 50 kilonewton meter. Similarly, MFCD is equal to MFDC is equal to minus 100 kilonewton meter. So this is all about our calculation regarding with fixed end moment. Now we have to distribute the moments, which we already done in the non-sway analysis. Same way we have to do, but we have to use these moment values for calculation. Let us consider the member. This is A, B, C and D. Here at B there is a joint, at C also there is a joint, at B the distribution factors we have to use already whatever we done. The same we have to use, that is 0.5. This is also 0.5. This is 0.571 and this is 0.429. So these are the distribution factors at joint B and at joint C. Now the fixed end moment, yes, we have to use these fixed end moments. So AB it is minus 50, BA is also minus 50, BC doesn't have anything, CB also doesn't have anything, but CD, yes, minus 100 and DC also minus 100. Now we have to transfer. We already transferred from B to A as A is fixed, from B to C and C to D as these two are the intermediate support. Now here your D joint is itself a simply supported joint. That's why we have to balance it. How will you balance? Add the opposite same value, that is plus 100, and transfer a half to the near end. It will be 50 now. Now next is nothing but we have to add values and we have to show that at D point it is 0. How we will do? Just add this value. We will get answer as it is minus 15. This is minus 50. This is again minus 50 and this will be 0, which completes our problem. Now next, which completes the balancing. Now next what we have to do? We have to balance the moment. We done the balancing at only point D. Now we have to balance the moment at B and C. What to do now? 50 into 0.5, 0.5 minus 50 into 0.571, 0.429. That multiplication we have to do and write down here with the opposite sign. Same what we done. So it will be 50 into 0.5 and write down in opposite sign. It will be 25. This will be 28.55 and this will be 21.45. Now we have to transfer half, where? From B to A, from B to C, C to B also, but here we don't need to transfer. So 25 divided by 2, it will be 12.5. It will be again 12.5. This is 28.55 divided by 2, it will be 14.28. Now next we got the values as 14.28 multiply with 0.5, 0.5, 12.5 multiply with all these distribution factors. So this 14.25 we multiplied, we will get 7.14, but we have to write down into the opposite sign. This will be minus 7.14. This will be minus 7.14. 12.5 multiply with 0.57 571, it will be again minus 7.14 and this value comes to 5.36. Now next what we have to transfer half, but where? To the fixed end. B to the A is fixed, B to the C intermediate support, C to the B intermediate support, and always remember intermediate supports are fixed one. So 7.14 divided by 2, it will be minus 3.57. Again it will be minus 3.57. It will be minus 3.57. Now what we have to do? We have to multiply this 3.57 with these distribution factors. 3.57 multiply with 0.5, it will be 1.78. It will be 1.78. It will be 2.04. It will be 1.53. Now next we have to transfer a half to the fixed end. B to the A, B to the C and C to the B due to this intermediate support. So 1.78 divided by 2, it will be 0.89. Again it will be 0.89. It will be 1.02. Now it is somewhat going closer. Now multiply these values with the again distribution factor. Same iteration we will repeat. It will be minus 1.02 multiply with 0.5, 0.5. It will be minus 0.50. It will be minus 0.50. It will be minus 0.50. It will be minus 0.39. Again dividing these by 2 and transferring to the fixed end. When we do that, we will get a final answer. Let us do another one iteration and then we will close this problem. Half 0.50, that is 0.25 minus, it will be minus 0.25, it will be minus 0.25, and this will be, no need to transfer from this. So now 0.25 into 0.15, so it will be almost closer to the 0.13. so this will be 0.13, this will be 0.13, this will be 0.15, this will be 0.11. so ultimately all answers are in 0 point something. That's why we will add now these moments up to the its end. That means from 50 to this point, from this line to this point, all column will going to be added. This comes to minus 40.44, this comes minus 30.74, 30.74, this will be 32.88. I think this will be again minus 32.88, and this will be 0. So this is all about moment distribution. Later on, our next steps is that we have to do a sway analysis, that is we have to calculate a sway force for sway analysis. Earlier we calculated sway force for non-sway analysis. Here we have to calculate a sway force for sway analysis. This can be same as it S dash is equal to HA plus HD. Now here I had written H dash, HA dash, HD dash. So ultimately this is the addition, that is nothing but minus 40.44 plus minus 30.74 divided by height is 6. So we will divide it by 6 plus HT dash, that is these two, minus 32.88 plus 0 divided by height is 3. So ultimately we will get a S dash is equal to 20.088. So this is all about sway force due to the sway analysis. Earlier it was sway force due to the non-sway analysis. Now we want to write down a sway correction factor. Sway correction factor is denoted by K, and ultimately it is the ratio of S divided by S dash, that is a sway force due to non-sway analysis to the sway force to the sway analysis. That is nothing but sway force due to the non-sway analysis was 1.76 divided by 20.088. ultimately this comes to minus 0.0876. now which completes our problem, but only the last step is remaining, where we have to add all our final moments which we calculated. Now let us write down first the final moments we calculated due to the non-sway analysis. So here we have joint B, here is a joint C. Ultimately we will write all the moments. First we will write the moment due to the non-sway analysis. Due to the non-sway analysis we get the moment as, at A it was 31.00, at B it was 62.22 minus 62.22, at C it was 51.91 and minus 51.91, and this value is 0. This was due to the non-sway. I will write down here non-sway. These are the non-sway moment. Now what we have to do, we have to write down all these sway moments also. This is somewhat assumed sway because we assumed something, so that's why it is assumed sway. We write down same, that is minus 40.44. This is minus 30.74, then 30.74, then 32.88, minus 32.88, and this is 0. Now what we have to do, we have to multiply this assumed sway with correction factor. So we will get a actual sway. So let us calculate a actual sway. How to calculate an actual sway? Actual sway, there is one formula I am writing here. Actual sway is equal to K, that is correction factor, multiplied by with assumed sway. So using this formula we can calculate actual sway, that is minus 40.44 into minus 0.0876. if we multiply it, we will get an answer as 3.54. again this will be minus 2.57, this will be 2.57, this value will be minus 2.88, and this is 2.88, and this comes to the 0. Now the last step is nothing but we have to add all these moments so that we will get a final moment, that is addition of actual sway plus assumed and non-sway, that is non-sway plus actual sway. So I can write down here a formula which you can remember, that is final moments. I'm writing here final moments is equal to non-sway moments plus actual sway. Non-sway plus actual sway, that is nothing but 31 plus 3.54. so ultimately it will be 34.54. the next 62.22 minus 2.55, it is 59.65. the next minus 62.55 plus 2.57, it is again minus 59.65. the next 51.91 minus 2.88, it will be 49.03. minus 51.91 plus 2.88, it is minus 49.03, and this is 0, which completes our formula, and these are the final moments after calculation. So which completes our problem of our sway analysis. So let us revise how we calculated. First we calculated non-sway analysis, and then we calculated a sway analysis in this sway frame. So there are total 9 steps. If you remember this, you can solve any problem. Thank you for watching. Kindly like, share, subscribe. Excel Engineering Education.